Hi guys, we are back. We are still on this question or challenge. We had finished part A. Yes, we had gotten this one. Thank God. So let's embark on the second one. Show that RS is 2q tan beta out of p sine alpha. RS. It's like the height of this vertical tower. Remember they say that RS is a vertical tower. So we want like the height of the vertical tower RS. So thank God that here they said show that RS is this. Someone may want to trick you and say that show that the height of the vertical tower is this, so we have to keep our eyes open. And this is a show that it's not a proof. I think we all know that show that and prove that in maths are like somehow different. Prove that you may start from the left hand side to the right hand side and show that both sides are equal, or you can start from the right hand side going towards the left hand side. Show that of course we have to start from this side no matter what. Let's go right to what brought us here. We want RS is what we want. So let us try to sketch. We want this. So if this is our tower, trying to visualize, this is our tower RS. We are sketching this triangle, because we can't use this one. Why not? Because this is the side, or this is the triangle which has most of the known elements. We have beta, and from this is a horizontal line. From what we know, let me show it here. This is the horizontal from R. You see this line? This is the horizontal from R. And this, if this is R, this is S, this is a tower. We don't know this. This is what we want. We don't know this. This is K, but we know this. This we have. Now, since this angle of depression of R from K is, or R to K is beta, these angles are going to be equal. So this is beta. Okay, this is a horizontal line, this is a horizontal line. These guys are going to be equal. Okay, they are alternating angles. So we have SK. We thank God we don't have this. Probably we don't even need it. We want this. What do? We want this opposite. We have the adjacent. We have the angle. This is clear, right? So we can say that tan of this angle, from tan we use opposite and the adjacent. Okay, so we know that tan beta, because in our expression we are showing that, you have to be referring to what they want in the question. Don't just go astray and do your own things, then realize at the end that you went off track. Okay, so you have to be cross-checking with what they want. One of our teachers used to tell us that you have to think like the person who set the question. So what does this guy really want? So we see that this guy has tan beta here. Okay, so let's come here and say that now we are thinking like the examiners. Tan beta, tangent of the angle beta. I think we all know that beta is the second letter in the Greek alphabet, alpha being the first one and omega being the last. Okay, tan beta is opposite, which is RS, out of adjacent, which is SK. Since we want RS, this guy we cross multiply and we come up with RS being equal to SK tan of the angle beta. We can have a smile, at least we have tan beta. Okay, we have tan beta. So let us proceed and punish this question. But we know that from above we got our SK. Let us substitute it here. But SK is 2Q over P. We can put the sign down. Why? Why am I writing it down? Because the question wants sine, not cosec. Okay, so ideally someone who stopped here would have gotten all the marks. But the funny thing is that if you fail the first one, or if you had failed the first one, there's no way you would have gotten this, and there's no way you're going to get this. Okay, because it's like a chain. So part C and part B are dependent on part A, so you have to be careful and you have to be neat, okay, to win marks. Impression matters. So let's substitute here. So this implies that our RS, like I said, you can always put a bar on top that to show that this is the distance. RS, we substitute here, right? 2Q out of P sine alpha times tan beta, or tangent beta. Make it look nice. 2Q tan beta out of P sine alpha. That is our RS. So don't put in a lot of swag. As required, QED, whatever, hence proved. No, this is enough. Just put one line. Okay, there's nothing you're proving. Okay, don't waste a lot of time putting 4 lines, 5 lines. Okay, just go to the next question. There's no time, especially if you're in an exam. Okay, don't waste time. So from this we are going to part C of this question. Interesting. We've scoped these marks as well. So part C, what is it saying? It says that calculate the size of angle alpha if this angle is complementary. What does it mean? I think we all know the types of angles. For starters, complementary angles or acute angles, angles less than 90 degrees, supplementary greater than 180. Okay, reflex, all those, please go and revisit that. And so whatever you do, if you're getting R, they've given you a condition that R should be less than 90 degrees. It should be acute. Obviously, it should be acute. Okay, because the sum of these angles add up to 180. Okay, so these angles add up to 180. And looking at this triangle, I don't think that this angle can be, okay, it can, but according to the condition they are giving you, according to how this guy set his question, maybe but R may be greater than 90, but according to how he set his question, this R cannot be greater than 90, so it should be less than. And RS is 70 meters. RS. So coming back to this, we have RS. Okay, we have RS. We want alpha. What else do we want? Do we have? We have P. Yes, we have P. We have Q and beta. Yes. Looking at this, RS is known, Q is known, beta is known, right? Everything is known. It's just alpha. So we can gladly and happily use this without wasting any time. So some questions would even start by saying, hence, calculate the size. Okay? So it means there's no way you can get to part C without first being sure that part B is correct. I know some guys somehow stumble, like somehow they try to be smart, and from here, or somehow they fail to come up with something. They just come up with RS is equal to this, hence proved, and they think that we are happy. No, we are not. We shall find out and we shall arrest you. So please, don't try to be smart or to outsmart examiners. Okay, so from this, we know that this is what we want. We have RS, this is what is given. RS is 70 meters. P is 80 meters. And Q is 2500 square meters. I know you're not happy while I'm saying that, but it is 2500. And beta is 42 degrees and 0 minutes. Okay, I think you know that minutes are also units for angles. And 1 minute, we know, is 60 degrees. Okay, yeah, when we reach that point of projectiles, we shall be looking at minutes, measuring angles in minutes. It increases the accuracy of your answers. Okay, it's like saying meters and centimeters. Okay, so from here, let us cross multiply right away to bring the term which has alpha in it up. So we cross multiply. We shall have P RS, okay, P times RS times sine alpha. I've cross multiplied. This entire thing is 2q tan beta. I know you're not happy, but I'm going to substitute these guys after. Divide by P times RS. You may put this if you want. By P times RS. Therefore, these guys are going to cancel. I told you guys, don't cross out. Okay, I'm just showing you that these guys are leaving this side. They are breaking up with the sine alpha. Sine alpha is equal to this expression, P times RS, and of which, when we substitute, we see that 2 times, it's not point, but times, okay, Q, everything is in the right units, okay, to 500 tan beta is 42 degrees out of P is 80 meters. So when you cross check square meters and meters, everything is fine. And RS is what? 70. You can write the 7 like that if you want. Okay. When we use a calculator, this guy will give us 0.03932182441. I'm using this number of decimal places because we want to keep the accuracy. The degree of accuracy has to be high or up, because I'm going to use this value to get alpha. Okay, so alpha is the sine inverse of this value. Okay, sine inverse or arcsine, whatever you want, of 0.8039321821. So our alpha is, if you have a good calculator, should be able to get this. This is 6 degrees, and this was, this is 5 decimal places. Always record the accuracy, the limit or the degree of accuracy you've used. I've used 5 decimal places. Decimal places, these are the places or positions where this decimal point can move to on the right. So, or the number of digits after the decimal place. So this is 1, 2, 3, 4, 5. Whereas, if we are looking at significant figures, I know those things confuse people, especially our physicists, physics guys, okay? Significant figures, how many are these? 1, 2, 3, 4, 5, 6, 7. These are 7 significant figures. So they will tell you, write your answer to 7 significant figures, or 5 DPs, 5 decimal places. 0 here, is a significant figure because it is between two non-zero values. Thank you for following. Let us go and follow our YouTube channel, Alan Mark, Facebook, Alan Mark. Don't forget to pray. Jesus loves you. Work hard. Read your books. Thank you. Have a nice time.